A system of two equations. Every equation can represent a graph. So we have two equations. So we have two lines. These are linear equations we'll be working with. Two lines can either intersect at one point, that we would say it's one solution, not intersect anywhere, that would be no solutions in the case of parallel lines, and an infinite number of solutions as if the line intersected itself everywhere or two lines were exactly overlapping each other. So when we say we're going to solve a system of two equations, what we're saying is we're going to find out whether these two lines that are represented by these equations are intersecting at one point, not intersecting, or intersecting an infinite number of places. What you do is we're going to use the elimination method. You try to eliminate one of the variables and then work with one variable at a time. You could multiply times whatever number you like, and you could do it to any equation. So I'm going to multiply 2 times this equation. So it's 2 times 2x, 2 times negative y, 2 times 1. Then I just slide this one over, and I combine like terms, column by column. 4x plus 3x is 7x. The y's cancel, and we have a 6 on this side of the equation. Then just solve for the x. So x is 6 over 7. We use that x that we found to find the y, and we do that by plugging it back into one of the equations. So if I plug it into this equation, the 6 over 7, and I simplify, I'm going to isolate the y. I'm moving everything away from the y. Notice at this point I have this. I have the y by itself, almost, but there's a negative 1 here. Get a common denominator, combine these two, divide both sides by a negative 1, and you have y equal 5 over 7. The solution is 6 over 7, comma 5 over 7. You always put the x first and then the y. This would be the point of intersection. So those two equations represented two lines that are intersecting at this point if we were to graph them. Here's another practice problem. So we have two equations, notice, and two unknowns. For every unknown, you need an equation. You have xy, that's two variables, you need two equations. We're going to multiply the first equation by a 2. Even though we need this 2 just for this position, we have to multiply the whole equation. What you do to one side, you have to do to the other. So after multiplying, this is what we have. Then slide the second equation underneath. Combine like terms, go column by column combining. In this case, it gave us something that's kind of strange. It's saying that 0 equals 0. When you get a case like this, it's either true or false. 0 equals 0. A number always equals itself. That's true. When you get a true, then we have an infinite number of solutions case. This is the case where you have an infinite number of solutions. In other words, the two equations of the lines that were given represent graphs of two lines that are intersecting everywhere, an infinite number of times. Here's another system. So we're going to go ahead and multiply the first equation by a 2. This is the result. Just slide the second equation over. Combine like terms. And this time we get a false statement. 0 does not equal 15. When you get a false statement, that means there is no solution. We're talking about parallel lines. Remember, a solution are points of intersection. So if there's no solution, the lines are not intersecting. So this lines must be parallel. We have a word problem where we're adding on to the problem is that we have to read the problem and come up with the equations ourselves. So 800 people attend a baseball game and total ticket sales are $3,102. If adult tickets are $6 and student tickets are $3, how many adults and how many students attended the game? So we have two questions, the adults and the students. That's like X and Y, two unknowns. So we're going to need two equations. First, identify who's going to be who. We're going to let the X be the adults and the Y's be the students. Then you read the problem and describe it using the equations. For example, it says that there's 800 people. That means adults plus students would equal 800. Adults plus students equals 800. So this equation tells you how many. Then write another equation that brings in the money, takes into account the money that's involved. It says that adult tickets are $6, so the X, which represents the adults, gets the 6. And student tickets are $3, so the Y, which represents the students, gets the 3. And then also says a total sales is 3,102. So you put these two money amounts, they should give you a total of $3,102. So one equation brings in the how many people are we talking about? And the second equation brings in the money part. From here on, it's the same as before. We could multiply the first equation by a -6. This is what you get. Slide the second equation underneath, and then go column by column, combining like terms. These cancel. We have the y, and we have the constants. Now just get that y by itself. Divide both sides by a -3. So that gives us a y of 566 students. Remember, the y were the students. Then the one that you found is going to help you find the one that's missing. So we found the y. So go ahead and substitute this y value into one of the equations. It doesn't matter which, you get the same answer. So the first one looks like the simplest. So I'm going to replace the y here by 566. Then I'm going to solve for x. In other words, get the x by itself. So I move everything away from the x, and I get x equals 234 adults.